Day class. It's Sir Capistrana again, and welcome back to another discussion here in Physics 1, General Physics. We're in for today. We'll be talking about, actually, this is just a continuation, per se, of our past discussion regarding kinetic energy and work. And for today, we'll be looking into the other side of that kinetic energy. As you may have remembered, there are actually changes occurring during the movement of an object. So in that, kung maaalala nyo, merong pag-decrease or pag-increase no kinetic energy ng isang body during motion. Pero di, di ba sa mga past discussions natin or dun sa mga earlier lessons nyo during your high school days, nababanggit doon na meron tayong tinatawag na conservation of energy or the law of conservation of energy wherein energy can neither be created nor destroyed. It can only be transformed from one form to another. So dun sa increase at decrease ng energy na yon, saan napupunta yung kinetic energy na sinasabi natin? So in that note, we will be looking into that basics na pinag-usapan natin yon. The other side of that coin of kinetic energy is actually what we call the potential energy, and in which we will be considering energy conservation. So in that, let's look into kinetic energy and potential energy first. As you may have remembered, kinetic energy is actually an energy that is associated in motion. So we are considering here the when we talk about kinetic energy, this is just the one half of the mass of the body multiplied to its velocity. And as you may have noted last time, it is actually related to motion. It is associated in motion kasi makikita natin na kapag meron tayong tinatawag na quantity or kina-quantify natin yung kinetic energy, the body is actually in motion. And when we talk of that energy, the other side of that coin is the potential energy. And but by that potential energy, this is actually the energy that is associated in position. And for today, we will be looking into that energy associated in position in a way na dun lang muna tayo sa pinaka-generic na distinction ng tinatawag nating potential energy na yan. Kasi basically, when we are talking about potential energy, uh, lagi natin pinag-uusapan kung saan lang nakapwesto yung isang bagay. So, kung saan nakapwesto, uh, ang the general distinction natin ng potential energy is when we place an object in a certain height, it actually has an energy that is stored depending on its position from the ground or yung tinatawag nating earth. So in that, we will be also looking into the total mechanical energy wherein when energy is conserved, it is just mechanical energy is just the sum of the system's kinetic and potential energy. So it just means na yung kung pinag-uusapan natin yung yung total mechanical energy, it is just equal to our K eh, and our U. And but by that U, we'll be looking into that U as our potential energy. But that U will actually be used as the distinction of work done by gravity. And by gravity, we'll be looking into potential energy. And by potential energy, it is actually defined as the energy in stored form. Yun yung lagi na nating alam during our earlier years of our study. And it is commonly associated to the weight of the body and its height from the ground. And to be exact, it is actually called gravitational potential energy. And by gravitational potential energy, yun nga, it is actually the energy that is associated to the weight of the body and its height from the ground. Okay? So, by potential energy and kinetic energy in action, one of the example na pwede nating tingnan dito ay yung sa ating basketball. Okay? So if we are to throw a ball in a certain direction, as it ascends, ma mapapansin natin na nag-i-slow down actually yung bola. So in that, actually, kung isipin natin, halimbawa, this is the initial position of your throw, and you throw the ball in a certain direction bago siya umabot dun sa hoop, or kung papasok man siya or hindi dun sa iyong hoop. Anong mangyayari dito? So, if we are to look into potential energy and kinetic energy in action, if ang pag-uusapan lang natin ay yung kinetic energy, anong nangyayari actually, syempre, once you applied a certain force or you applied force to that ball, as it goes up, nagkakaroon actually tayo ng decrease in our kinetic energy. So, in that, kapag tinitingnan natin yung decrease in kinetic energy na yan, ang ibig lang sabihin yan, meron tayong increase ng ating potential energy, or for this note, we'll be using U. And in that, at this point, dun sa highest point ng ating nare-reach ng bola, ito yung point kung saan pinakamataas yung ating potential energy. And as it goes along in its journey, halimbawa, nagtuloy yung movement ng ball natin towards the hoop, ang nangyayari dyan, class, pataas ulit yung ating kinetic energy, okay? And pababa ulit yung ating potential energy. So that is our potential energy and kinetic energy in action. So basically, as it ascends, ibig sabihin, habang pataas yung bola natin, there is a decrease in the speed of our ball, kasi constant naman yung mass niya, dapat hindi magbabago yun. In here, kapag pataas yung movement ng ating bola, the kinetic energy decreases and the potential energy increases. While it descends, syempre nandun na pababa na yung ating bola. Ibig sabihin niyan, yung na-store natin na energy at this highest point, nako-convert na siya into kinetic energy. So, ano nangyayari? As the kinetic energy increases, magdi-decrease yung ating potential energy. So, that is how we usually see our kinetic energy and potential energy in action. So, pwede rin natin yung isipin na halimbawa sa isang inclined plane, pag mataas yung plane mo or taas yung inclination mo, kung mapapansin nyo, at this point, halimbawa, meron kang gulong or bola na nandyan sa point na yan bago siya mag-slide. At this point, ito yung point na pinakamataas yung potential energy mo. And kapag nag-descend siya, pa-increase yung kanyang kinetic energy as long as walang ibang body or walang ibang forces na tawag dito, mag-i-interact or ipipigil dun sa action mo. Okay? So, habang pababa siya ng pababa, ayun, tumataas yung ating kinetic energy at this point. Okay? And, syempre, dahil na-convert na lahat ng potential energy natin, or hindi naman lahat, most of our potential energy into kinetic energy, bababa naman yung ating potential energy dito. Okay? So, that is how we see our potential energy and kinetic energy in action. Pero, doon muna tayo sa pinakasimple, yung tinatawag nating gravitational potential energy, wherein we will be looking into it during free fall. So, free fall, hindi natin i-consider muna ang ating air resistance. So, in cases na tayo ay mag-consider ng tinatawag nating gravitational potential energy and we will be looking into work, meron tayong pwedeng maging dalawang scenario kapag i-move natin ang isang body vertically from an initial height. So dito sa unang example, dun sa A, we actually have here a system that wherein yung ating body ay mag-move downwards. So, ito yung kanyang initial position and ito yung kanyang final position. As you may see here, Y1 is actually higher than Y2. Ibig sabihin yan, when a body moves downward, anong nangyayari dito? So, since ang consideration natin ng displacement tayo ay y2 minus y1, since y2 is lower, So, magkakaroon tayo diyan ng y2 minus y1 which is actually less than zero, which means uh, we have here a positive work kasi yung motion natin ay downward din. So, we have a positive work and we actually have a decreasing gravitational potential energy. So, in this scenario naman sa kabila, we have here a body that moves upward. Ibig sabihin, may motion tayo na pataas, pero meron tayong displacement na pataas din. So, it just means na magkakaroon tayo ng negative work in consideration of our gravitational potential energy. Ang ibig lang sabihin yan, tataas yung ating gravitational, yung potential gravitational energy. Okay? So, paano ba nakukuha yan? So, basically, it is just from the formula din ng work natin. So, in consideration of work and consideration of gravitational forces lamang, we will have here yung formula natin dati, ginagamit lang natin ay yung ating force times our displacement. And in here, the only force that we have is our weight. Okay? And our displacement is actually y2 minus y1. Okay? So in here, we can also equate this into mass times the acceleration due to gravity, which is 9.8 meters per second squared, multiplied to our y2 minus y1. Okay? So basically, we will have here a formula which tells us that we will have here mass times the acceleration due to gravity times y1 minus our y2, which is mass times y1 to. This is y2. Okay? So we will have here this formula. Okay? So in that, as you may notice here, baliktad yung scenario natin. Ano? Kasi ang tinitingnan natin dito ay yung movement from nung ating na cause nung ating gravity instead of the motion itself. So, in here, magiging baliktad yung mga positions natin wherein for the gravity, our final position will actually be our y1 and our initial position will be y2. So, medyo confusing lang but in any case, we can simply write that as u grav or yung potential energy natin ay equal lamang sa ating mass times or gravity or acceleration due to gravity multiplied to our vertical displacement. So in here, yan yung ating gravitational potential energy. Okay? So in here, ayun, baka magkalituhan lang tayo. Usually, ang changes sa ating U-grav ay actually laging negative. So, ayun, baka lang malito tayo ron sa mga nangyayari dito. But in any case, kapag yung body natin, ang motion niya ay upward, meron tayong positive na gravitational energy kasi as you may have remembered, G is always negative kasi yung movement natin ay laging pababa. And kapag naman ang movement natin ay pababa, mayroon tayong decreasing uh, na gravitational potential energy. Okay? So that is our formulas for our gravitational potential energy. Okay? Alright. So moving on, clarify lang natin regarding sa gravitational potential energy. GPE is the potential energy associated with body's weight and its height from the ground. However, it is incorrect to call GPE as the gravitational potential energy of the body. Hindi natin pwedeng sabihin na yung GPE na yun ay nag exist lang dun sa body. So, bakit ganon yung sinasabi natin? It is not correct kasi kung iisipin nyo, ang GPE kasi ay isang shared na quantity. So, bakit natin siya tinatawag na shared quantity? So, ang sinasabi lang natin dyan kasi, when we are talking about gravitational potential energy, it is a shared property between the body itself, yung object na hawak mo, at saka yung Earth mismo. Okay? So, bakit kailangan natin i-consider yung yung effect or yung property ng Earth towards dun sa body natin? Because as you may have remembered, kapag itinataas natin yung isang object from the ground, tumataas ang kanyang gravitational potential energy. At pag binababa natin siya, palapit sa ground, pababa naman yung kanyang gravitational potential energy. And in that note, that the form, yung characteristic na yon ay characteristic mismo ng body mismo. Kasi yung mass ng body yung kinukuha natin. And also, we will be looking for the value of yung sa Earth kasi kino-consider natin yung G or yung ating acceleration due to gravity. So that's why it is called as shared property between the body and the Earth. So hindi natin pwedeng sabihin na ang GPE or yung gravitational potential energy ay gravitational potential energy lamang ng body. Right? So it is the gravitational potential energy of the body and the Earth. Okay? So now that's clarified. Let's look into some let's look into the conservation of mechanical energy. So in consideration of gravitational forces only, sabi nga natin kanina, kapag nag increase yung ating kinetic energy, pababa yung ating potential energy. So in that consideration, we will be actually having this relationship wherein if we are to look into the total, kung maalala nyo, let's look into the kinetic energy muna. Sabi natin last time, ang total work done or yung total work is actually just equal to the change in kinetic energy or yung tinatawag nating change in K. It just means that this is equal to our K2 minus our K1. And also, when we talk about the work or the total work of ng potential energy, this will be equal to the total work ng ating gravity. So, ang mangyayari dito, this will actually be equal to the negative change in our gravitational potential energy, which is just equal to our u grav 1 minus our u grav 2 or the gravitational potential energy 2. So, kapag inequate natin yung sa isa't isa, what will happen here is we will actually have a system wherein kung titingnan nyo, parehas silang equal sa total work. It just means that our change in potential energy or kinetic energy is just equal to the change of our gravitational potential energy or the negative uh, of our gravitational potential energy. It just means that when we are dealing with conservation of mass or conservation of mechanical energy, we will have here a system wherein our K2 is actually K1 minus K2 is actually equal to our U grab 1 minus our U grab 2. So, in that note, pwede na natin ding isulat ito in a way na ang mangyayari, our K1 minus our plus our U grab 1 is actually equal to our K2 plus our U grab 2. So, anong ibig sabihin lang nito? So, when we are dealing with conservation of mechanical energy, yung initial na kinetic energy natin or the sum of our initial kinetic energy and initial potential energy is simply equal to the sum of our final kinetic energy and our uh, final potential gravitational potential energy. So this is in consideration of gravitational forces only acting on an object. This will be our conservation of mechanical energy. We can actually use this in a way na magiging equal siya ron sa mga quantities ng ano natin, na ginagamit natin last time. So isulat ko lang siya sa red. Sabi natin dati, ang kinetic energy ay equal lang sa one half ng mass times the velocity of an object. So, or the square of the velocity of an object. So, meaning to say, we can write this formula na ganito yung magiging itsura niya. So, we will have here one half of our mass times our initial velocity squared plus the mass times the acceleration due to gravity of then multiply natin yun dun sa initial position is equal to the one half of the mass of the body times its final velocity squared plus the mass times the acceleration due to gravity multiplied to its final position. So that will be our total mechanical energy or yung tinatawag natin conservation of mechanical energy. So in a way, we can actually use this na para ma-equate natin or ma-compute natin yung mga bagay-bagay within a system. Halimbawa, gusto mo makuha yung highest point ng isang object mo kapag tinapon mo siya sa air. Pwede mong sabihin na yun yung y2 mo. Ang given ka lang ay meron kang mass at meron kang initial velocity ng object mo. So, paano mo may compute yung height? So, mga ganong bagay yung pwede natin gawin dito. Kasi, in a way, pwede rin natin dito makuha yung total mechanical energy ng isang system natin by simply getting one side of this equation. So, halimbawa, this one, yung K1 plus yung first GPE natin or yung gravitational potential energy natin is actually equal to the total mechanical, the initial total mechanical energy of the system. And dun sa kabilang side, yun naman yung magiging final natin. So, basically, ang total mechanical energy natin will be just equal to our K plus yung ating U. So, if yan ay gravitational forces lamang ang nag-exist. So, meron ka pang ibang forces na nag-a-act dun sa body mo, magbabago yung value ng ating total mechanical energy of the system. This is the total mechanical energy of the system. Okay? So, let's have an example dun sa sinasabi kong pangyayaring yan. So, ayan, ito yung sinasabi nating conservation of mechanical energy when only gravity does work. Wala tayong ibang forces na nag-a-act, wala tayong air resistance, wala tayong spring or kung ano man. So, the total mechanical energy is constant and it is actually conserved. So, yun yung sinasabi ko kanina. In a way, na kapag ikaw ay mag-move up or yung motion mo ay moving up, magkakaroon ka ng decrease dun sa iyong K. And once na ma-reach mo na yung highest point ng iyong move up at ikaw ay pababa na, this is more on like a projectile, your K actually increases. And at the same time, once as your K decreases, your gravitational potential energy actually increases. And also, our U-grav decreases kapag naman nag increase yung ating K. So, anong ibig sabihin lang nito? Constant yung ang ibig lang sabihin niyan, constant yung ating total mechanical energy. And it is actually conserved. So, in a way, uh, pwede natin itong makita na yung total energy ng system, actually, pwede natin tingnan as zero in some way, pero hindi yan pwede. Okay? So that is our total mechanical energy when we only have gravitational forces. Right? So let's have some computation. So we'll be looking into the height of a baseball from energy conservation. So in here, imagine throwing a 0.145 kilogram baseball straight up, giving it an initial velocity of 20 meters per second. Find how high it goes. So kung dediretsuhin lang natin dun sa kinetic energy yung discussion natin or yung way kung paano natin isosolve tong problem na to, medyo mahihirapan tayo. Bakit kanyo? As you may have remembered, our kinetic energy is equal to the 1/2 of the mass times its velocity squared. Okay, may ano ba kayong nakikita dyan? Wala tayo dyang value for the position. And that value for position is actually makukuha natin yun dun sa ating U-graph. Dun sa U-graph, we can actually get the position by simply using U-graph since the formula for our gravitational potential energy is mass times the gravity times y. So by y, this is actually equal to mass times gravity uh, multiplied to our, ano na nga ba ito? To our y1, nga ba? Y1 minus y2. So, yan yung titingnan natin ngayon. So, basically, kung ito-drawing natin yan, ang sabi niya, dun sa ano natin, meron kang bola. Yung bola ay itinapon no pataas. Nagkaroon ka ng movement ng bola mo at a certain height. So, gusto nating makuha yung y2 na ito. Okay? So, ito kasi yung ating unknown. And also, yung mga quantities na meron tayo, initially meron tayong 20 meters per second na velocity sa motion natin. And it has a mass which is actually equal to 0.145 kilograms. Okay, so yan yung ating mga considerations when it comes to this motion. So basically, kung i-consider natin na uh, yung position, yung initial position nung ano natin, nung throw natin ay equal sa 0, so mas madali natin itong compute. So, basically, we have here the initial height. We have here the final height, pero unknown. We have the velocity and we have this mass. So, in here, pwede na natin actually magamit yung ating formula. So, by formula, as you may have remembered, so K1 is actually K1 plus U grab 1 is equal to our ano ba to? U grab 1 equal to K2 plus our U grab 2. So pwede natin gamitin tong buo. So isulat lang natin yung mga form, yung ano natin, yung form natin kanina. So that will be mass times 1/2 times the mass initial velocity square. Then we will have here our mgy1 is equal to 1/2 times mass times the velocity or the final velocity plus uh, our mgy2. Okay. So, considerations. So, makikita natin dito, class, ang sabi natin nun sa ating pag-aaral regarding sa ating throw using our free-falling bodies. At this height, sa Y2, kung ma-imagine nyo, ang velocity natin dito actually ay equal to 0. Bakit? Kasi dun siya mag-slow down at its highest point. Ang ibig lang sabihin yan, kung i-consider natin itong second kinetic energy natin, since 0 ito, magiging 0 na tong buong equation na to. So, this is actually just 0. And as you may see here, dito rin sa ating initial position, ang initial position natin ay 0. Ang ibig sabihin, yung y1 natin ay 0. And if we multiply any number by 0, this will be actually equal to 0. It just means that we will be only using these sides or parts of our equation wherein we will have here our initial kinetic energy equal to our final potential energy. Okay? So by final potential energy, we will have here our mass times acceleration due to gravity multiplied to our y2. So as you may see here, andito na yung y2 natin. So using this equation, we can actually divide uh, both sides of the equation by mg or the mass times acceleration due to gravity para ma-cancel natin siya dito. So we will be left with just y2 in this side of the equation. Compute na natin yung y2. And we will have here, as you may notice, maka-cancel out yung ating mass. So we will just have here 1/2 multiplied to our velocity squared or our initial velocity divided by g. So pwede rin natin itong isulat as our initial velocity divided by 2 times g is equal to our y2. Okay. So, for the computation, you just need to substitute lahat ng quantities na meron tayo. So, we will have here, isulat ko ng pabaliktad na class, associative naman ito, or commutative naman, sorry. So, we will have here y2 is actually equal to our v1 squared. So, we will have here 20 meters per second. We just need to square that all over our mass, our 2 times the acceleration due to gravity, which is 9.80 meters per second square. So, upon computation, kunin lang ulit natin yung ating calcu. Okay? So, we will have here 20 square. So, we will have there 400. 400 divided by 2 divided by 9.80. Okay? So in the end, we will have here a value which is equal to 20.4. Okay? So we have here 20.4. Ano na nga ito? Since white ito, that will be actually meters. Okay, so paano natin nakuha yun? Kung mapansin nyo, ito ay magiging meter square, second square. Meron tayong meter square, second square. Magka-cancel yung second square. Magka-cancel din yung isang m or meter natin dito. So we will be left with 2.20.4 meters. Okay? And that will be the height of our throw nung sa ating 0.145 kilogram baseball straight up. Okay? So that is how we use our the equation for our total mechanical energy or yung tinatawag nating energy conservation. Okay? So, paano naman class sa mga scenarios na hindi lang yung gravity yung nagdo-do ng work? So, in case of other forces doing work on the body, the initial work will be the sum of the initial kinetic energy, the tawag dito, the gravitational potential energy, and the work done by other forces. And it is the sum of those initial work or initial energy will be actually equal to the final kinetic energy and the final GPE. So in that note, sulat ko na lang siya kung paano natin gagawin yun. So we will have here our kinetic energy. So that will be our initial kinetic energy plus our initial potential energy plus the work done by other forces. Okay? So, isulat natin dito na other. Okay? That will be equal to the final kinetic energy, our K2, plus yung ating GPE or yung ating U2. Okay? So, bakit iyan? Bakit wala ng other forces na ano? Kasi, ang iniisip natin dito yung work ng others or yung work ng ibang forces na ginawa na nangyari dun sa system ay nangyari lang during dun sa initial stage at hindi siya na-existing during the final stage ng ating motion or ng position ng ating moving body. So, we have there that relationship. Okay? So, sorry about this, but that will be all. That will be all for now. Medyo groggy pa rin kasi ako from my booster shot, but in any case, Thank you and have a great day ahead. Bye.